Okay, today's lesson we're going to look at solving exponential equations. And an exponential equation is just like any other regular equation, except we got x as being part of the exponent. So we can't just do simple dividing and adding, subtracting rules like we do with other equations because of that x being an exponent. But what we're going to look at is a way to solve these things where you can make it a fairly easy equation. So the method we're going to start with is just basically making sure the bases are the same. So if I give you two equations, if I give you 2 to the 4 and I had something like 2 to the 5, those are not equal. So if they're equal, that means that exponents also have to be equal. If the bases are the same, the exponents have to be the same, otherwise they wouldn't be equal. So our strategy then is going to be, if I gave you 3 to the 4, is that the same thing as 9 squared? And the answer is yes, because if we can change 9 to be 3 squared, and 3 squared squared is indeed equal to 3 to the 4. So our whole strategy for this is going to be make the bases the same. If the bases are the same, then that means the exponents are the same. So let's start with this first example. We got 3 to the 2x equals 8, equals 3 to the 8. Bases are the same, so we're good. So that means the exponents have to be equal. So that means we can basically ignore the bases, and 2x has to equal 8. Divide by 2 on both sides, we get x equals 4. So it's a pretty easy equation to solve as long as bases are the same. So here's another one. We got 11 to the 2x plus 6 equals 11 to the 2. Bases are the same. So just make your exponents equal to each other, and then we would solve. So bring the 6 over, divide by 2, we get x equals negative 2. And if you weren't sure, you could plug that back into the original. So if we put negative 2 in, we'd have 2 to the negative 2, which is negative 4, plus 6. That would give us 11 to the 2, which is the same as the other side. So you can always plug it in to see if you got it right. Okay, so here's another one. We look at it, we say, okay, bases are not the same. So the question is, can we make them the same? And in this case, the answer is yes. We can change 81 to be 9 squared. So just rewrite the question with 9 squared instead of 81. And then what we want to do is, now that we have both bases being 9s, we can just worry about the top. So we have x plus 3 equal to 2 times 2x plus 9. And then we would solve from there. So we'd have x plus 3 equals 4x plus 18. And let's bring the x over. So we'd have 3x plus 18. Bring the 18 over. And divide by 3, we get negative 5. So it works pretty good as long as you can make those bases the same. So what we're going to find out with a lot of these kind of questions, the hardest part sometimes is just making the base the same. So a couple of rules we want to remember. So if we had exponents where we had something like 2 to the 4, and we're going to multiply that by 2 to the 3, the rule was if the bases are the same, we add exponents. So remember that. Another one is if I gave you something like 2 to the 4 in brackets to the 3, that rule was multiply the exponents. So that's one we should remember. Another one that causes some problems is when we get square roots. So something like square root of 2, that's the same thing as 2 to the 1/2. So because that square root has a little 2 in there that we don't write, that tells us what the fraction part of it is. So the root of 2 would be 2 to the 1/2. And another one, if I gave you something like a 1/2, that would be a negative exponent. So that's the same thing as 2 to the negative 1. So let's go through each of these. Let's change all of these to be equal to a base 2. So 32 would be 2 to the what? So 2 squared is 4, 2 cubed is 8, 2 to the 4 would be 16, 2 to the 5 would be 32. So if you're not sure, just use your calculator, plug it in, and away you go. So this next one we got 16, so that would be 2 cubed is 8, so 2 to the 4 is 16, so we'd have 2 to the 4 for just the 16, and then to the power of 3, so that would be 2 to the 12. That one's pretty good. Here we got a square root, so that would be square root of 4, so what we want to do is we want to change the 4, so 4 would be 2 squared, and then the square root would make it a 1/2, so 2 times a 1/2 would be just 2 to the 1, or we could write it as just 2, which square root of 4 is equal to, so we're good. Here's a cube root one, so we change the 16. 16 would be 2 to the 4. And then a cube root is a third. So we just multiply those, so that'd be 2 to the 4 thirds. So that's not too bad. And our last one, we've got 1 over 64. So just worry about the 64. 64 would be 2 to the 6. Because it's 1 over, that would make it negative 6. and then we have a third, so negative 6 times a third would be negative 2. And that's it. So the hardest part often is just rearranging those bases, and once you have that, the rest of the equation is pretty good. So here's another question. Bases are not the same, so let's change 25 to 5 squared. And let's change 125 to 5 cubed. Now that our bases are the same, we can just solve our exponents. So 2 times 2x equals 3 times x minus 1. So we'd get 4x equals 3x minus 3. Bring the 3x over. X equals negative 3. Okay, here's another one. 7x equals 3579. So this one's pretty tough. You can't figure it out in your head. So what you need to do is check to see what is 7 to the power of 4. So 7 to the 4 equals 2401. So that's too small. Let's try 7 to the 5. 16,807. So definitely it means it's going to be a decimal. It's not in between. So we could guess and check. So you could try something like 7 to the 4.1 or 7 to the 4.2 or something like that. And you would get pretty close and you could narrow it down. The other option is to graph. And so any of these kind of questions, if we can't solve them by making the bases the same, what we're going to look at doing is graphing. So let's graph y equals 7x, 7 to the x. So that would be our exponential equation, so it looks something like that. Then we want to graph y equals 3579, which is just our horizontal line. So on your calculator, you might have to adjust your window settings or whatever, but graph both equations, so you can see where they cross, and then we'd find that intersection point. So you can see in this case, our x equals 4.205. So if we went back to the original question and put 4.205 in for x, that would equal 3579. So for now, we're going to learn logarithms in our next lesson, and we're going to use that to solve these. But for now, the easiest way to do a question that you can't make the bases the same is to graph both sides and find the intersection point. And that's all.